Hello, sixth graders. This is Mr. Burns. I'm the science teacher in the boathouse. And today we're going to focus on a couple new topics. One of them is called diffusion, and the other one is dissolving. Go ahead and grab out your science notebook and turn to your table of contents because we're going to update it. If you want to put in today's date, which is February 8th, so in your table of contents, you're going to put in 2-8-21. Our topic is diffusion notes, and that will go on page 41. When you finish putting this into your table of contents, I want you to flip to page 41 in your notebook and title it Diffusion Notes and put a page 41 on there. As in the past, as we flip from slide to slide, you want to make sure that you copy anything that is highlighted in yellow. If I'm moving too fast for you, remember you can always hit the pause button so that you can catch up on your note taking and then hit play when you're ready to move on. All right, we'll start with diffusion first. If you want to copy down what you see highlighted in yellow on this slide. And diffusion is the process by which molecules spread from areas of high concentration to areas of low concentration. Below on the slide, you see a picture of what that looks like, kind of a visual aid there. Each of those blue circles represents molecules, and in the picture on the left there, you see a high concentration of molecules. Essentially, a lot of molecules squeezed together in a small area, and then over a short period of time, they begin to spread out a little bit more, so that it's a little bit less crowded, the middle picture. And then over a longer period of time, they begin to spread out even more, the picture on the far right there, where we have a low concentration of molecules, and they're not so crowded together. So one of the analogies I try to think of when I think of diffusion is this. Think about if we had to put 50 students into an elevator at one time. It would just be jam-packed in there. It'd be a high concentration of students, very crowded. And then eventually the elevator's doors open up to the gym at Rosemont Middle School, and all 50 people move out into the gym and spread out and kind of get their own area. That's kind of what diffusion would look like. Let's look at some real life examples of diffusion. The smell of cooking pizza spread throughout your house, putting food coloring in water, and pop going flat, losing carbonation to the air are all good examples of diffusion. If I circle back to the first one, the smell of cooking pizza in your house, I always think of it like this. Sometimes you come in from outdoors, and as you walk in the house, you can smell pizza, or you can smell popcorn, or you can smell freshly baked cookies. You can't see them yet because you haven't made your way to your kitchen yet, but you can smell them. That's a great example of diffusion at work. Putting food coloring in water, you'll see the example in the middle of the slide there, where when you initially put that drop of food coloring in the water, there is a high concentration of food coloring, and then it slowly starts to diffuse out, as you see in the picture there. And pop going flat, again, if you leave pop sitting out for a long period of time, eventually it loses its carbonation and it's diffusing into the surrounding air around it. Okay, next I'm going to have you draw the following picture in your science notebook. The beakers of water with the dye, as well as the labels that you see highlighted there. And what's going on there is that a person is putting some purple food coloring into a beaker of water. And what they're trying to show there is a high concentration of food dye, and it is moving to areas of low concentration in beakers 2 and 3. So when we first put that drop of food coloring in there, we have a high concentration of food coloring or food dye sitting there. Over the next couple of minutes, we would be able to see diffusion at work. as we take a look at beakers 2 and 3 there. So in beaker 2, we see diffusion taking place. The food dye molecules are starting to spread out, and then many minutes later in beaker 3, they have completely spread out, and we are at what's called an equilibrium. Okay? And at that point, in this particular beaker, it would be completely purple, and it would be the same shade of purple. So if we go back to the first beaker there, it's mostly water with just kind of a one little blob area of purple food dye. And then a few minutes later, as it's diffusing in beaker 2, you would see some that purple dye starting to diffuse out or spread out, and you would see kind of a mix of purple and clear water, and it'd be kind of swirly looking. And then many minutes later, picture 3, you would see the same shade of purple throughout the course of the beaker. And this whole process is achieved through something called diffusion, and that's when the high concentration of food dye moves to a lower concentration through diffusion. Moving on to a new topic that you're probably more familiar with, we're going to get into dissolving. And when we dissolve something, essentially it means to form a solution by mixing evenly. And examples of dissolving would include sugar into water, as you see in the picture on the left, or dissolving a drink powder in water, the example on the right. So when we're dissolving different substances into a liquid like water, essentially it makes it look like the substance disappears. When you put things like sugar into water, or salt into water, or Kool-Aid into water, okay, and you start to mix it up and dissolve it, you can no longer see the sugar or the salt or the Kool-Aid. It looks like it disappeared. Now, it didn't. It's still there, but it's mixed in so well that it forms a solution. You can no longer see it. Okay. Now, there are things that won't dissolve into water. For example, if I put some pepper into water and stirred it in there, when I got done stirring it in there and mixing it up, you would still be able to see the pepper flakes very easily in there, so they wouldn't disappear, for example. Or if you put sand into water and mix it up, you would still very easily be able to see the water from the sand. And when things don't dissolve, we call those insoluble. All right, that wraps up our notes today on diffusion and dissolving. I hope everybody has a good day, and goodbye.